going to talk a little bit about some of the new features that we're going to start seeing in JavaScript this coming year. Technically, the release of the JavaScript specification that's coming out next June will be called ECMAScript 2021. It's almost a little confusing and a bit of a weird name because most of the features I'm going to talk about are actually finalized and in many cases ready to use today. And it's actually a pretty exciting year for JavaScript because a lot of these changes are sort of small quality of life improvements that people are going to use, will probably end up using every day. That hasn't necessarily always been the case. A lot of the recent features have actually been sort of very down in the weeds, very niche use cases. I'm also going to talk about a stage 2 proposal. So it's not finalized yet, but it's the one I'm most excited about. And that is the temporal proposal, which is going to be basically add a modern, significantly improved date library to JavaScript. With that, I'm going to just dive in and talk just a little bit about how we got here and why is this called ECMAScript 2021. So in 1995, JavaScript was released as sort of a feature on the Netscape browser. It was sort of developed in-house. It was developed by a guy named Brendan Eich in like 2 weeks. And it ended up being fairly successful. It was sort of the first way you could make web pages interactive. And about a year later, Netscape kind of realized that, okay, this is going to become a thing. It's now a part of the web. And they reached out to an organization called ECMA to sort of set JavaScript up as a standard that other manufacturers could implement. By the way, ECMA stands for the European Computer Manufacturers Association. I did not know that before I wrote this presentation. And when they set up the standard, they set up what is called TC39 or Technical Committee 39. And those are just the people at ECMA who are responsible for JavaScript. I only mention that because you're going to see their name pop up a lot when we're talking about new features. So you sort of run through the timeline in the 90s and you see that, a couple months later, ECMAScript 1.0 was published. ECMAScript 2 came out a couple months after and was a minor revision. And like sort of at a pretty quick pace, we released ECMAScript 3, which actually did add a fair number of new features. And then things kind of go off the rails after 1999. Work starts on ECMAScript 4, people disagree, it turns into a mess, and 10 years go by without any major new features being added to JavaScript. Or I should say being added to the spec, because the web didn't pause for those 10 years, and people at different browser manufacturers did kind of add features, and they kind of went their own way, and it wasn't great. Standards got fragmented, new standards were informal, and eventually things kind of come together. And in 2009, ECMAScript 5 is published. And a lot of what that did was to just codify and standardize a lot of the progress that had been made, but not really written down. From there, people were excited. We started developing new JavaScript features, and we kept talking about this thing called ECMAScript 6. And one thing led to another, and we couldn't decide what features should go into ECMAScript 6, and there was this long push to get it perfect before it was released, and another 6 years go by. And during that time, again, people started using bits of that draft spec, and it just sort of was like this weird gray area where no one really knew what they could use or when they could use it. So yeah, another 6-year gap, not great. We kind of learned from that lesson. In 2015, we were like, all right, this is never going to be finished. We're going to rename ECMAScript 6 to ECMAScript 2015. And just once a year, we're going to take whatever's ready and release it. And we've been doing that ever since. So the previous process was a little too much focus on getting things perfect, and it led to just way too much time passing between releases. And if there's one thing about the tech industry, it's that we don't like to sit still. So no one was happy with this. Features didn't make the cut, or sometimes features did make the cut and we rushed to get them there. And again, no one ends up happy with that. So basically, ECMAScript became a living specification where proposals are evaluated and adopted continuously. So once we decide that like a new feature is ready, it'll become part of the spec in June of the subsequent year when it's published. But the spec being published almost doesn't really matter. Once a proposal reaches stage 4, it's done. It's going to go into the spec as it's written when it hits stage 4. And that's sort of when browser manufacturers, the people who write Node, can start implementing it and adding it. So in fact, for literally all but one of the features that I'm going to talk about today, they're already in the current version of Chrome. They're already in the current and actually previous version of Node. So everything I'm going to talk about is pretty usable today, despite the fact that it's still 2020 and these are the features that are going to go into 2021. So quick rundown, it wouldn't be a standards body if they didn't have a boring flowchart like this. Basically, proposals start at stage 0 where someone is like, hey, I have a cool idea. And then they sort of run down this waterfall, and eventually when there's good consensus in the community, we've sort of built a polyfill, built some Babel transpilers to test out the new feature in the wild. We decide that it's done and ready. I kind of have my own interpretation on the side of what these stages mean. Stage 0, we observe, just kind of say, oh, that's nice, someone had an idea. Stage 1 is when sort of things start to get going. We start collecting feedback from developers. And then stage 2 and 3 are kind of the work in progress, where we have a pretty good idea of what we want the feature to look like, and we want people to sort of test it out and hammer on it. And sort of when things reach stage 3, they actually tend to be pretty stable and don't change much apart from small details. So that's where you can start using things like Babel and like transpiling things and actually using them in your code, because you have a relatively safe you can make a relatively safe assumption that nothing major is going to change between the time that between stage 3 and when the feature is actually published as stage 4. So there's currently 5 proposals that have reached stage 4 that'll be included in the spec next year. And 4 of them are actually things that you may end up using every day. So that's really exciting. We haven't had that sort of much everyday, like that much forward progress on what I would call everyday JavaScript, things you're just doing in your day job. Nothing complicated or super weird. So the first one I'm going to talk about is probably the most boring ECMAScript proposal that we've ever had, and that is numeric separators. You can now add underscores to numbers. They don't do anything. That's it. So normally if I want to write a big number, 1 with 9 zeros, 1 billion, it's kind of hard to read. Under the proposal, I can add underscores there just to make that more readable. Also works for hex and binary. You might not know this. You can actually write hex and binary numbers just straight out in JavaScript. That was one of the things added in ECMAScript 2015. And to make those more readable as well, you can add underscores. So for instance, like the CSS color Alice Blue, CSS colors are divided into the 2 numerals for red, green, and blue. And we can add those underscores to make that a little easier to read. Similarly, if I'm writing something out in binary and I want to break it up into 4 bits at a time, I can do that as well. Also, it doesn't matter where you add them. They have to be between the first and the last digit. You can't have consecutive ones, but you can put them wherever you want. For instance, if you were doing like using integers for like currency, like $100, you could write as 100 underscore 00. Anyway, yeah, you can kind of go crazy with it. Don't go crazy with it. Don't write that example there at all, but yeah, you could. So that's it for that feature. The next one is also a relatively simple and straightforward one. String.prototype.replaceAll. Currently there is a string.replace method. So I have the words badger, badger, badger. And if I wanted to replace, that's not the right example. There should be a replace badger with mushroom. Sorry about that. I wrote the wrong code example. It'll only actually replace the first instance of that word. There's a shortcut that there's sort of a hack workaround you can use where if you write the replacement as a regular expression and add that /g, the global flag, it will replace all instances of that in the string. But it's just it's a little awkward. Like if I want to replace a string that's got a lot of special characters in it, I've got to write out a regular expression that escapes all those characters, and it just kind of looks like regular expression vomit in my code. So the replacement to this is the solution here is pretty obvious. There's a new string method called replace all, and that will actually, replace all instances of that string instead of just the first one. Again, nothing terribly groundbreaking, but a nice little convenience that, makes your life a bit simpler. The next one is probably the weirdest looking one, and the only sort of fundamental change to how the language is, the syntax of the language. So something that comes up a lot in general programming is sometimes I'll have a function or something that accepts a value, or it might accept a value. If in this example, function example, if a is undefined, I want to, set a to foo. Just have some default for a variable for, a setting that might not be there, whatever. And, I'm sure everyone's written some variation of this code probably 1,000 different times. Possibly more commonly, if your options are an object, that object may not contain all the settings you're looking for. And again, there are a variety of ways you can set defaults, but at the end of the day, you will often end up writing code that looks a little bit like this. If options.setting is roughly equivalent to null, let's put a value there. So Extra 2021 is going to add 3 new operators to sort of make this add a shortcut for writing out things like this. The one that you're probably going to see most commonly is the logical OR assignment. So like that first example, I have in my function, I say, if A is falsy, A set A to B. Cool. So currently with the OR operator, I can do something fancy. I can short circuit and say, because the OR operator will, basically if you have a chain of ORs, it'll run whatever's in there until it hits something that's truthy. So on line 5, if A is truthy, I'm not going to run what's to the right of the OR. But if A is undefined or not set, or false or 0, actually, we'll get to that in a second, then I'll actually set A to some other value. The new operator on line 7 is literally just the OR operator with an equals after it. And all it's doing is saying, if A is unset, then set it to B. There's also an equivalent version of this for the AND operator. This one's a little weird. Basically, you're saying, if A is set it to something else. I tried a very long time to think of a place where you'd use this, and I couldn't really come up with one. But if you're under a circumstance where you expect A to be false or undefined, you can set it to something else. And finally, the nullish coalescing operator, which is very similar to the OR operator. It was introduced, I think, 2 years ago into JavaScript. And basically, it's like the OR operator, but it doesn't work on, so in this instance, if A is, it'll only change the value of A if A is null or undefined. So if A is 0 or false, it'll leave that there in this example. And that's good for a lot of configurations where false or 0 are actually valid values when you're setting defaults. Take a quick look at how you would use this. I would say for most people, the nullish version, the question mark equals, is going to be what you use the most. And here on an object, I want to set opt.setting to something. I want to say, if that's not set it to a default. And here, that's what I've done. It's set to a default. In the second example, there's already a setting provided. So line 3 does nothing. Nothing horribly groundbreaking, but this lets you express this concept much more clearly and in fewer lines of code than what you can do today. The next proposal is an improvement to promises. So right now, many of you, if you've worked with promises, have probably used promise.all. And basically promise.all is saying, I want to run a bunch of asynchronous code in parallel. And and give me the result when they're all complete. One sort of caveat to promise.all is that if any of the promises you give it fail, the whole thing fails immediately, and it doesn't necessarily wait for the rest of them. So if I have 5 promises and 1 fails, I'm not going to wait for the other 4 to finish. And I'm just going to throw an exception for that failure. Also, a little less common is promise.race, which is basically saying if I give it 5 promises, just take the first one that finishes. And not just the first one that succeeds, but the first one that fails or succeeds. Again, for some performance stuff, like if I can ask a question from 2 different sources, and I know they're going to give me the same answer, I just want to pick the one that's fastest. The downside here is that failing immediately, that if I have 2 sort of people I can ask a question of, I really don't care if one fails. In ECMAScript 2018, we also added another one called promise.allSettled, which solves one of the problems here where, sometimes we, if one promise fails, we do care about the others. This one basically is, it'll always succeed with an object that tells you which of your promises succeeded and failed. But the cool thing about it is, if one fails, you can still get the values out of the other. And I think you can see where this, there's a bit of a gap here in terms of, that case I described earlier, where if I can ask a question of 2 sources and I just want the first one that answers, and I don't care if one fails, there's a new method for that, promise.any. And basically that one is sort of a version of race that doesn't care if, just one of your promises fails, and it'll only throw the exception, or return a failure if all of them fail. So this is really nice for circumstances where, again, I can, this is a very dated reference to the show Who Wants to Be a Millionaire, where, I can guess my answer by, eliminating half the answers, calling a friend, or asking the audience. And in this contrived example, I only care about who gives me the answer first and successfully. So in this case, promise.any, if say, phoning a friend is the fastest thing, that'll be the one that returns. Yeah, we don't care if we don't care who answers, we just care that someone does and what the first answer is. Right. Moving on, the last proposal in ECMAScript 2021 was actually one I wasn't going to talk about, but a couple people apparently asked about it when they signed up for the talk. So I'm going to go over it really quickly, and that's weak references. In ECMAScript 2015, we added 2 new features called weak set and weak map. And both of those were designed around memory management, specifically so we could hold on to a reference of an object and still allow the JavaScript engine to garbage collect those objects sort of when it decided it was done with them. There's a couple of reasons you would do this. They're all fairly niche, to be perfectly honest. But at the end of the day, it's sort of both weak set and weak map are a place you can put things that you don't really care about, but might want later if the browser has decided that it's still available for you. So both weak set and weak map objects, if you put them in a weak set or weak map, the JavaScript engine may garbage collect those objects. Usually that would only happen if you're not holding a reference to that object, like no variables are assigned to that thing anymore. The engine would come through and reclaim that memory. Here, weak set and weak map sort of provide a place to put objects where the garbage collector won't come and try and steal, or I'm sorry, they will still come and try to steal them away. It's sort of the way of saying, I care more about the memory usage of my application than actually holding on to these things. Both are actually kind of weird to use in practice. Weak sets actually don't let you access the things in the set once you put them there. You can only sort of check to see if an object was already there. Similarly, a weak map sort of works the opposite of how you would think. The key to the weak map is the thing that's weak, not the object itself, which just sort of makes it very weird and cumbersome to look up values in that map. Generally speaking, what people use both of these for are DOM nodes and virtual DOM implementations. You can read up on some of the techniques that people use them for, but generally speaking, you would sort of use it to see, is someone actually is this DOM node being referenced by anywhere else, or can I reclaim it and reuse it somewhere else in my tree? Similarly, in the weak map, you would use that node as the key, and then the values in that map would sort of go away if you remove the DOM node from the DOM. All this is a way to say weak references, weak maps, and weak sets are very niche features. There's a lot of pitfalls to them, and most of the things that you might want to use them for, you probably have better alternatives available. The first big issue is that garbage collectors are complicated. They have very complicated algorithms to decide when and why they're going to remove something from memory. The behavior of the garbage collectors also can vary considerably between different browsers, different browser versions. On Node, jumping a major version will often dramatically change the way the garbage collector works. Similarly, your platform, the garbage collector's probably going to take into account the amount of RAM you have available. So it's going to behave differently on a server versus a web browser versus on a mobile phone. It also doesn't necessarily guarantee you're not going to run out of RAM. Again, because it uses complicated heuristics to decide when to run garbage collection, there are scenarios in which you can actually run out of RAM, even though you freed up references that the garbage collector could have come and collected. Another way of saying is nothing's guaranteed in garbage collection. It's unpredictable, and if you're relying upon it for any specific behavior, you're probably going to be disappointed. And if you're not disappointed, when a new version of a browser comes out, it's probably going to break something. If you're wanting to build a cache, and that's what most people using weak references really want, it's probably best to just build a cache directly instead of relying on the garbage collector to sort of be the thing that decides how much to fit in your cache and when to evict things. There's an NPM package called LRU cache, short for last recently used cache. And basically, it's a very simple library. It's like 100 lines of code, and it keeps references to things that you might want later if the lookup's expensive, and it only keeps a certain number of them and evicts the ones that have been accessed least recently. Super low tech, but again, if you want a cache, I would really emphasize just use a cache. Don't use weak references. Also, if you are stressing this much about memory allocation, JavaScript might be the wrong language for your project. I don't say that lightly, but once you've gotten this far into the weeds, it might be time to step back and think about what you're doing and what technology stack you've used. I use JavaScript almost exclusively. It's a great language. It's not necessarily one size fits all. So basically, weak references allow you to build what is effectively a better weak map where the values are the things that are being garbage collected. So for instance, if I have, say, some browser code that's capturing video or fetching video and saving it into memory, I might want to keep, those are obviously going to be very large objects that take up tons of memory. I might want to build a map where I'm just like, hey, let's keep these around just in case we need them. But also, we don't care if the garbage collector decides to kick them out and they're gone forever. So here we would just build a map that looks a lot like a normal map, except our values are weak references. And from there, I can get video 1 or get video 2 if they're still there. Basically, to access the value inside of a weak ref, you just call that dref function on it. If the value's been garbage collected, it'll just return undefined. There's one pitfall to this approach, which is that when the browser garbage collects, say, big video 1, we're actually still going to have in our map that the key, the number 1, as well as the empty weak ref object that it was holding it. Along with the weak ref spec, there's another spec being written called the finalization registry, and that allows you to register a callback to do cleanup once the weak ref's been scavenged. Once again, there's a lot of caveats with it. There are actually cases where those callbacks won't run. You can't depend on them for cleanup logic. If you actually go and read the proposal, they devote about 3 times as many words to why you shouldn't use any of these features as they do to describing the features themselves. So buyer beware. So of these 5 features, 4 of them are pretty safe to use today. 2 of them are virtually safe to use almost anywhere. Numeric separators and string.replaceAll are supported in pretty much a couple recent versions of Node and every modern browser, including Safari. You can use them today. You should probably still transpile them, but to be perfectly honest, most browsers are going to see in the wild, with the exception of IE and Edge, are going to support these out of the box. Logical assignment operators are a little riskier, supports slightly less. I think CanIU says about 75% of users in the US will have browsers that can use them. Luckily, if you're transpiling, the Babel transform for these is super straightforward. So, there's no real harm in saying, use Babel if you want to do the logical assignment operators. Like I showed in my example, you can pretty much visualize what Babel is going to do to transform those operators into sort of legacy syntax. Promise.any also supports a little less. It's also one that is very easy to polyfill. It's pretty easy to envision how you would write out the implementation for promise.any. So it's a small polyfill. You can use it pretty much anywhere. Weak refs, I've just got done explaining why you shouldn't use them. There's another reason, which is that they're not supported in many browsers. I don't believe the current version of Node supports them, and only the very latest version of Chrome and Firefox support them. It's not really a feature you can polyfill just because it requires a very deep level of access to the browser's garbage collector. So for now, unless you're doing something extremely niche and know what you're doing, probably don't use weak refs until support is a little more widespread. So that's it for stage 4 proposals. There's a bunch of stage 3 proposals active right now. Only 2 of them were really, I thought were particularly interesting to me. The first one is top level await. That one's fairly straightforward. If you're familiar with async functions, you can await promises and other async functions using the await keyword, but you can only do that inside of an async function. Top level await lets you write it at the root level of your script. This is especially nice in places like Node, where maybe you want to do some startup initialization logic, like connect to a database or download some settings. You can just, in your root index.js file, just write await and not have to do the async stuff in a function. The second one is private methods. If you've used TypeScript or most other object-oriented languages, you'll see you're probably familiar with private methods and private fields that are only accessible within the class, not accessible outside the class. And you can kind of see here, today you could write TypeScript with just the keyword private in front of a method or property. In JavaScript, we're going to be able to use a hash sign and do the same. Nothing terribly groundbreaking. So, sorry, having to move a little fast here, but I'm going to talk a little bit about the temporal proposal. And because it's still in stage 2, I'm going to focus a little more on the why of the temporal proposal than the current actual implementation, although we will get into that in a bit at the end. So temporal is designed to be a replacement to the built-in JavaScript date object, which, if you've used JavaScript for a while, you probably know it's a little cumbersome to work with and has a lot of pitfalls. It's very easy to shoot yourself in the foot unintentionally with the existing JavaScript date. So temporal tries to fix this by being fully immutable, meaning you can't change the value of a date once you've set it. And also provides separate data types for a couple different types of date. specifically like partial dates. And we're going to get into that in a second as well. Again, it's at stage 2, but actually right now the polyfill and documentation for that polyfill are in really good shape. So I definitely recommend checking it out, looking at it, and sort of seeing what you think. So immutability, if I, JavaScript has the const keyword, and if I, assign const color equals blue, color's always going to be blue. Nothing will change that. And that's nice. Like, if I want something to stay the same, this is sort of making a guarantee for me. It's not nice when your program pulls the rug out from under you. However, objects themselves, the properties inside of the object. So yeah, if I had an object, colors again, colors will always be that object. But sorry, I've lost the slide. Yeah, I can't reassign like the object itself, but I have that same object. What if I call evil function? Evil function, even though colors is a const, I can actually, it still allows me to reassign properties. So evil function, prints the object, but it also does something evil, and it changes the object, changes my favorite color from blue to red. And now in my function that called that, or in the context I called that from, my favorite colors also changed to red. This is again an example of like pulling the rug out from under you. Like, you can say that mutating variables is frowned upon, which yes, it is. And you would never write code like that, and you probably wouldn't and shouldn't. But with dates, it gets a little trickier, because in this case, I'm using the moment.js library, and here my evil function is this very innocent looking function that prints tomorrow's date. But because moment is mutable, today plus actually changes the value of today, meaning that once I've called evil function, it's actually just keeps bumping the day by one day into the future. Again, this is almost certainly not what you wanted to do, but both the JavaScript date library and moment make it way too easy for you to do that. So let's talk about time and why Temporal and some newer date libraries have lots of different data types. So I'm just going to list some times. These are all kind of the same time, but they're not really the same time. Like, there's a Unix timestamp there. There's a bunch of dates and time zones. They're all kind of the same time zone, but to a human, all of those roughly mean the same thing. But out of context, all of these have different levels of precision and accuracy. Now, if I create a new JavaScript date object, it makes this giant thing, which, ooh, that's a lot of stuff in there. Like, I don't know when I said like the current date, did I really mean like just November 18th? Did I mean the current time? Did I also mean like the current time in this location? Now, imagine you're building a date picker for kayak.com. A naive way to do this would be, I'm just going to use a JavaScript date object for all of these things. And when I click on one, my React app will like grab that object so I can do stuff with it and like get the value and send it to a server. The problem is like there's a lot of stuff here that's not really relevant to the date picker. Like the time's not relevant, the time zone's not relevant. And this part in red is really all I care about. And the rest of that stuff is actually going to make it very easy for this to become a bug. We're running a little short on time, so I'll let you read this after, but sort of the gist here is, I'm going to make a naive approach to this date picker, make a bunch of date objects, and, store them. And, date 0 should be November 1st. But because I did this at night, it was actually 11 p.m. Eastern time. And that is actually, November 2nd rather than November 1st in UTC. So when you send this to your server or you like call to ISO string on it, you might actually end up shifting your day by 1 day unintentionally. Just because those like pesky time values that you thought were irrelevant were actually still there and they come back to bite you. Yeah, because I forgot to strip the time off or set it to a safe value to ISO string, converted to UTC, and shifted the date by 1 day. I can be clever and say, oh, well, just strip the time off after I run that, but it'll have already converted for me, and I'm still ending up with November 2nd there. Now, maybe I use a library like Moment, where, theoretically it's supposed to be a little more direct. And once again, this one, that should be November 1st, but it'll give me November 1st, but then it'll actually be November 1st, 5 a.m. UTC, which again, there's a risk there because it's still doing some time zone math. And if my server doesn't expect a UTC timestamp, it might mess things up. And the big thing that's been lost here is that, in the context that we were using this date picker, people are only seeing dates, but our date library and data types aren't really reflecting like the fact that there's less information shown to the user and sort of contextually what that information was. So I'm gonna skip this. We're running out of time. Basically, another way of saying that is all that extra information when I wrote new date that is like jammed into that date object, that can actually be worse for conveying the meaning of a date or time because it's ambiguous and you're not telling it which parts of the date and time you actually care about or were relevant to the user in that context. So most dates fall into 3 categories. If we're talking about a date or a time, we could be talking about a specific fixed point on the timeline, which is what we usually use Unix time or UTC for. That's, this moment happens at the same time everywhere in the world. You can also say a time at a given location, which is kind of equivalent to the last one, but might be different in terms of how you render it. So, I have a UTC time with an offset, and that produces 12:30 p.m. in Washington, D.C. And finally, like the date picker example or some other ones, you only have a fragment of a date, which is context specific. Something like Thanksgiving, birthdays, date pickers. In the example I skipped over, I was going to talk about, my birthday's May 5th. But if I go to Australia, technically I was born on May 6th Australia time, but I'm probably not going to celebrate my birthday on a different day. Like sometimes context is really important, catching a flight, synchronizing your clocks. Other times, like a birthday, you actually want the date to be a little fuzzy. So yeah, most date libraries are built with a Unix timestamp at their core. The interface they expose is very heavily centered around that specific time at a specific location. But in practice, we often talk about dates in much more generous and ambiguous terms. Like the date picker on Kayak, for instance. I'm flying, which means I'm probably going to cross time zones. And that also means that, my local system time zone is not the right one for that date picker. Because if I'm, booking a flight from DC to California, I actually want California time for my arrival, not DC time. And you could build all that in, but it would become incredibly complicated. And what we really want is just, a data type that just, holds a month and a day. And Temporal does exactly that. It exposes a bunch of different data types that reflect a lot of the more common real world cases of how you would refer to dates. And the cool thing about it is it doesn't allow you to do unsafe conversions. So for instance, if I have a zoned date time, which is a date, a time, and a time zone, I can convert that to a plain month day, which is just a month and a day. Because it's a subset. On the other hand, if I have a plain month day, Temporal's not going to allow me to, infer anything about it that could, turn it into a zoned date time unless I provide that other information. So sort of safety and context are the name of the game. And like I said, these allow programmers to be explicit about the level of precision they're using and intend. And they also allow you to be explicit about whether or not your time zone is important, which, as in the example of the kayak date picker again, it's important ultimately, but it's not important in the date picker itself. And temporal helps us by, not including just sort of random times on your date objects if you really only intended for there to be a date. And it also helps you avoid some of those accidental or unintentional time zone conversions. If we're going to go back and look at that kayak example again, I can actually see how I would use that plain date data type instead of the a full JavaScript data object. And my server as well, because I do care about time zones, I'm still giving the location of where I'm flying to or from. So my server can actually compute the full zoned date time of the departure I intend, rather than doing it on the front end. This is also nice because my front end doesn't need to be aware of what time zone the airport's in and all that other stuff. What it also means too is I have a single source of truth. I'm not repeating the information about my departure time zone in this API call. I'm saying I'm departing on December 18th from Washington, DC. I'm not saying I'm departing at December 18th, midnight UTC or whatever. The server's putting all that together for me, meaning that there's a lot less ambiguity and it's a little more direct. The APIs are kind of what you would expect them to be. You can get, the current instant zoned date time, plain date. Nothing terribly complicated here. Similarly for parsing, Temporal will only allow you to parse ISO 8601, but it validates pretty rigorously. It won't let you put something in like November 2020 and have it guess. Again, libraries like the built-in date library and Moment guess, and they often guess wrong. So being more explicit here is a little nice. You can also construct dates from an object. You can do it both in a lenient way, where if I say I want the 13th month of the year, it will say, I think you mean December. Or I can, pass an extra option and say, hey, validate this for me. If I, say February 42nd, throw an error, please. Formatting is, again, ISO 8601 only. There's a different browser/JavaScript API called International, abbreviated INTL, that already exists. It's already standardized. And that is what the Temporal authors propose you should use to format this into a human readable string. The spec is still being developed for how International will work with Temporal. So kind of TBD on that one. So I think I've already answered this. So can I use it yet? Maybe. As a stage 2 proposal, it can theoretically undergo some changes. On the other hand, as far as stage 2 proposals go, it's in pretty good shape. So I would say play around with it. If you're doing a side project with a lot of date handling, give it a spin. The two big gaps are still parsing and formatting. If all your dates are ISO 8601, Temporal's got you covered. If you're parsing from other weirder formats and having to format into those formats, you're probably still going to want a library like Moment or Luxon or one of the others that have a couple more conveniences built in. Also, the internationalization API is a little awkward. So what you can do today, though, even though Temporal's not ready, there are other libraries that have come out in the past few years, like Luxon or JS Joda, that are immutable and actually have very similar data types to what Temporal is going to offer. I'd argue immutability gets you 90% of the way there, that if you're writing code with immutable dates and times, migrating to Temporal will be very easy for you. Similarly, you can kind of emulate some of those plain date time types by using ISO 8601 strings and just truncating them. If you want a plain date, do 2020-11-18 and chop off the time. That also gets you part of the way there, although it doesn't necessarily get you some of the like safety. So yeah, kind of a comparison of, the libraries you can use. My favorite right now is probably Luxon. It was written by the authors of Moment and corrects most of the mistakes Moment made. And it, inspired the development of Temporal and some of these other ones. JS Joda is a ported Java library that is actually very similar to Temporal, but is a little heavier, a little harder to use. And yeah, sorry, I kind of had to rush through this, but if you want to comment on any of these proposals or any others, literally anyone can do it. If you don't think you're the sort of person who should comment on it, you are exactly the sort of person they want comments from. They are pretty receptive to feedback, and literally anyone can get involved. And there's links to a few blogs and newsletters down there that cover some of these developments as they happen. Sorry I had to rush there. I'll open it up to questions. I'm around for a few minutes if anyone has questions.
Awesome. Thank you so much, Andrew. And if you don't mind, can you go ahead and switch over so we have gallery view again? Perfect. There we go. Great. So what I'm going to do now is if anybody needs to hop off, feel free to. No pressure to stick around. But Andrew, thanks for being willing to stick around for a few more minutes. So let's go ahead and open it up now to some discussion if you guys have any follow-up questions that you'd like to ask.
I have a question.
Sure.
So I guess I'm wondering, it all sounds good from a front-end perspective using these new date objects, but what happens when you send it to the server? Like, how does, I guess what I'm wondering, like, I'm going to send it to a database and it's going to get stored in like a SQL database as like a date time, right? So eventually it gets sent back to me. So the server also has to know about these date objects and has to know to send me back, just the plain date.
So,
or how would that work?
So Temporal will produce an ISO 8601 string when you're sending it to the server usually. And in that spec, actually, they do support most of the things that library talks about in terms of like, a date without a time or a month and a day, that sort of thing. So it is up to your server to know how to parse that and deal with it correctly. Again, there are backend libraries that sort of do the same, and it is sort of two sides of the same coin where, if you're eliminating ambiguity on the front end, you want to make sure you're also eliminating any ambiguity on the back end. As far as databases go, I think most major databases do have separate separate data types for dates without times, times without dates, or dates with times. If you're doing one of the sort of weirder ones, like just a month and a day, like you might be better off storing that as a string than a date, because it's not really a full date, and like the date math that your database is going to do would actually probably be wrong.
Great, thank you.
Yeah, no worries.
I didn't know that Moment was going to be deprecated or was already deprecated. When did that happen? Was it just that they didn't find it something they wanted to maintain, and obviously there's a lot of issues? Or
so it was deprecated just a few months ago in September, and it was sort of the writing was on the wall for a while, just in terms of the mutability issue, where like the API where date plus 1 day would modify that date. It was a big source of bugs, and there's a GitHub issue called Make Moment Immutable, where they were talking about rewriting the library to get rid of some of those dangerous functions. It is probably the longest and most contentious GitHub issue I've ever seen. It's been open for like 4 years and has like 2,000 or 3,000 comments. And in the meantime, the authors of Moment wrote a new library called Luxon, sort of as a proof of concept of what an immutable moment would look like. And sort of a lot of people have started using it. It's a pretty easy migration. And at the end of the day, like they decided that to just take their proof of concept and make it into a full-fledged library and sort of soft deprecate Moment. Moment's not totally unmaintained now, but they're sort of the recommendation is because of some of the pitfalls and caveats that they'd rather you use looks on, which addresses those.
Makes sense.
I believe that the moment and the temporal is actually done by the same, some of the same people. I believe Maggie Pint is maintainer of moment, and also one of the authors in temporal.
Yeah, and the a bunch of the people that developed the most recent Java date library, which was originally a library called Joda Time and became JSR 310 when it became a formal Java spec, were also involved in the temporal development. So there are a lot of people there who have a lot of experience. So temporal actually has a lot of lessons learned baked into it.
I'm kind of curious about weakref, especially because it's like recommended to stick away from it. So is it more, should we infer that that's a direction that the committee thinks the language might be going in the future? Is that something they're going to build on? Why is it around? And
I think it's mostly around for lower level libraries, like something like React, that need slightly more advanced memory management features, while at the same time understanding that those features may be implemented very differently in different engines. I don't necessarily think they see the language going in a different direction as much as that they've identified a couple of concrete but niche use cases where the functionality does make sense. Like React's virtual DOM is one big example where React will reuse DOM elements just for performance. And some of these things like weak refs and weak sets and weak maps allow them to just go through the DOM and be like, okay, is this DOM, is this element being used? Has it been reclaimed? No, okay, I can reuse it. So it's got some neat things for reference counting, but I think the reason there are so many warnings on it is that there are temptations to do other things with it, like build a cache, and that it's a lot less safe for that, and the behavior is probably not going to be what you want, even if the behavior looks like it does what you want on your machine. Just in terms of Java, in terms of garbage collectors, just acting very differently on different platforms. And generally speaking, they've avoided exposing anything like this, which is, I think, one of the reasons also why they've made these very narrowly scoped and a little difficult to use. That they want to make something that solves the exact need, the React virtual DOM thing, rather than building something that is going to encourage people to write code that's going to fall apart spectacularly when it hits production.
Can I add a follow-up to that real quick?
Sure.
If there's no objection. In fact, the weak references and finalization registry in particular is, to my mind, probably the most exciting, because it's one of the few times we get something that you can't actually do in any other way. Everything else is sort of, there's a way to do it in JavaScript already. We now have a nice way of doing it. The weak references is particularly nice, but the finalization registry is, I should point out, I used it the day it came out. I'd sort of been looking forward to it. And there are a lot of use cases for it, but yes, like it's been said, the reason why they warn is that you can't rely on it. It's not going to be something that you can deterministically say, yeah, you will be called. But some examples, if you do anything with web workers or workers, it becomes very interesting. Like Comlink, I've been waiting for it. I have my own version of Comlink that I wrote. Part of the problem there is because they mirror the classes or the function, whatever, in a thread. Once it stopped being used on one side, the garbage collector will grab it. It still exists on the other side, and that's where the bulk of the memory is taken up, and there's no way to know that you can get rid of it. But with the finalization registry, once it gets selected on one side, you can kill it on the other side as well, which is what I used it for. And the weak references, well, if you're loading up a lot of big files, and they might get used. The user, somebody might actually, oh, give me this file or whatever video, whatever you have in memory, but they might not. In that case, it's fine to let them go. If they are getting called, sure, it's there. And otherwise, if it's not, you're going to have to wait for a load because nobody's been, it's been collected since. So there are a number of use cases. The weak ref is very stable and deterministic and easy and fine to use. Finalization registry, much more marginal, but when you need it, it's the only thing that can do it.
Yeah, and yeah, I would say I like weak refs in principle a lot more than the finalization registry. That's been my experience as well.
Yeah, it's a lot more useful. If you look at the diagnostic channel, that's a new thing in Node that just came out as well. It's just a pub sub mechanism, like sort of global events. But he uses it a weak ref in there when you start up channels, in case there's nobody who has channel, it'll eventually get collected out. It's very nice, very simple. It's a single, like a page or two worth of code for that whole module, worth looking at for good use of weak refs.
Yeah.
I think expanding on the use in Comlink, that was the scenario that I was going to bring up too. It would be really interesting to see peer-to-peer communications between browsers and node servers that allow for remote process calls and using these low-level garbage collection in order to synchronize the states across all these different workers.
Yeah, exactly. And it is useful for that. And they are aware of it. I saw an interview or some little thing on YouTube with them where they talk about using specifically that because they recognize that it's an issue. I wrote an actor model, sort of an Erlang actor model, which has the ability to call code distributed across a network. And that's also really useful when something is not getting called anymore. Nobody has reference to it. Eventually, it'll go away. Somebody calls it, yeah, I can reload it. So anytime you have anything distributed, it is a really good. It's a really good hook to know that it's not being used here. So potentially you can get rid of it.
Yeah, it's nice to know that something's been definitely evicted on one side, but the one pitfall is like you don't know how long it's going to take for the garbage collector to actually.
Right, you don't.
The finalization registry isn't going to fire the callback until the garbage collection actually happens, which
but the alternative, you're right, of course.
The alternative is much worse. Yeah.
They said you never get told, and now it just sits there, and eventually you run out of memory. You can do max old space size, but eventually that's not going to work either. So.
Yep, for sure.